All right, welcome. Today we are talking about increasing and decreasing functions. This is actually a pretty straightforward topic. So we know from when we were talking about derivatives that the derivative of a function will tell us the slope of its graph at any point along the graph. We also remember from just general slope and lines that any positive sloped line is going to move up as we read the graph from left to right. This is what is known as increasing, right? Because our y values are increasing as we move across the graph. On the other hand, I know that any negative sloped line is going to be moving downward as I read it from left to right. This is called decreasing, right? Because our y values are decreasing as we move across the graph. So if derivative tells us slope and the positive and negative slope tell us whether our lines are increasing or decreasing, then in order to determine whether or not a function is increasing or decreasing, all we have to do is take the derivative and see whether it's positive or negative. Now, if we're looking at a graph, we're going to want to find points along that graph that sort of act as turning points. Right? So if I am looking at this function and I'm reading it left to right, my y values are increasing, and then I hit the top of this hill, all of a sudden, my graph changes direction. It falls to this little minimum point here, and then it turns around and increases again. So my graph is increasing up until I hit -1. So I can say that my graph is increasing where x is less than -1. Or if I'm writing that as an interval, that's negative infinity to -1. I also increase starting at 2 and everything past. So that's going to be wherever x is greater than 2. Or, if I'm writing it as an interval, that's everything from 2 to infinity. And finally, I am decreasing everything in between the -1 and the 2. So that would be where -1 is less than x is less than 2, or if I'm using interval notation, from -1 to 2. So luckily this time the points where we change direction were provided for us. But that won't necessarily always be the case. So look at the graphs, figure out whether they're increasing or decreasing, and then let's look at example 2. Unfortunately, I did not leave myself a whole lot of room. So what I'm going to do is look at the graph first on my calculator. And so if I draw the graph of the function, it's going to look something like this. Since I don't have the maximum and minimum points labeled, if I don't have those turning points labeled, I'm going to want to get the derivative. So my f prime is going to be 6x squared plus 6x minus 12. So let's say I graph this guy instead. If I do that, I get this little parabola. So remember we said wherever f prime is positive, f is increasing. Wherever f prime is negative, f is decreasing. So if I look at the graph of f prime, I notice it hits the x-axis at -2 and +1. If I go back to my graph of f and I count over to -2 and +1, notice those are the high and low points. Those are the points where the graph changes direction. So we are increasing when x is less than -2, or from -infinity to -2. And then we're increasing again when x is greater than 1, or we can say from 1 to infinity. Finally, the graph is decreasing in that middle section. Which has to go from -2 to 1. All right, so do the same thing for the next couple of examples. Draw your graphs. Figure out where the derivative is positive and negative, and use that to determine whether or not your functions are increasing or decreasing. That's all I have for today. I'll see you guys next time.